What is up, amigos? Today we're looking at the aerodynamics of a llama, and I don't actually know if you can ride llamas. I vaguely recall seeing like a full-grown human riding a llama, but anyway, I'm sure a child could ride one. So we have a wide plane at the very edge of the llama, so like its right side, and the wake is incredibly violent. Like I haven't seen a wake this violent for quite a while, and that indicates that there is a lot of unsteadiness coming from this animal. It's probably because the neck is quite thick and then the upper body is quite thick as well. Now we have a Y plane going through the mid section of the llama, and the wake is huge. Like the wake from the neck is massive, the wake from the legs are even massive. It's just a very wakey beast. And the drag coefficient reflects that. It's 1.01, which is like, it's quite difficult to get a drag coefficient that high. So this thing is bred to be draggy. And the wake is kind of a little bit of a down angle, not too much, but a slight down angle, and that means that there is a little bit of lift being produced, and the lift coefficient is actually a little bit positive. It's 0.09, not a lot, but still nothing, not nothing. Now we have the X planes going downstream, and it's really cool how unsteady this is. Like the third plane is pretty much how unsteady most other objects are in the fifth plane, and even in the first plane, you can see like two little blue lobes at the top. They're from the two ears and like the two sides of the head. So that's pretty cool. It's just a really wakey object. So now we have a Z plane right at the llama's feet, and this is a really unusual thing that we're seeing here because the wake is so big and still so like violently wakey, like it just fluctuates so much. It's like a massive oncoming streak that it's a little bit hard to believe. But we did see this kind of thing with the horse that we've done in the past. So for some reason, like these animals that have these four legs, when you go between the legs, the wake just grows dramatically. And I think it's partly due to the underbody, like when we saw the horse and the cow, for example, the underbody, like flow comes underneath that and it separates and there's this massive wakey region. But I think it's also from the four legs themselves that each produce a small oncoming themselves and they interact and just grow and just make a massive wake. So now we have a plane going through like the midway section of the llama. And interestingly, there is obviously a von Karman streak forming, which we expect from other planes. We've seen that as well. But the flow is a little bit asymmetric. So the flow over the top, like if you look from the top of your screen, the flow seems to be, the wake is quite a bit bigger than the bottom half. And so that means that the llama is actually, must be asymmetric around the Y plane there, like the plane going through the body. Because I aligned this llama like completely straight with the free stream direction. So this llama is probably a little bit asymmetric. So this plane here goes through the llama's neck, and you'd think at first glance that this entire wake is coming just from the neck, but it's not, because you can see that there's this pulsing near the neck where it's not left and right, it's just more like just this general pulse. That indicates some three-dimensionality, and it's probably from the llama's back, and maybe from the flow coming from over the llama's head. So this wake is really big, not just because of the neck, but because of the convergence of the wakes from the head and the back. So that's in the simulation. Make sure to like and subscribe. And if you want to get better at CFD and or theory yourself, check out courses in the link description. And I'll see you in the next simulation. Peace out, amigos.